I'm Anil Kumar, and in this video we are going to analyze graph of derivative of function. And in this particular chapter we are also going to understand how to find increasing decreasing intervals for a function, how to find the turning points for a function, and local maximum minimum of a function from first derivative. So let us first understand graph of the derivative of the function itself. Question here is a simple true or false question. Well, let me warn you first, 90% students get these questions wrong. So be careful and think before you answer these questions. You need to consider the graph of the derivative. This is the graph of the derivative. So the parabola upside down which you see here is derivative of a function, not the function itself. Now looking at this graph, you have to answer these questions and say whether these statements, the four statements given to you, they are true or false. So you can pause the video, copy the question, answer, and then look into my suggestions. Okay, the very first statement is that derivative at 0 is greater than derivative of the function at 1. Now since this is the graph of the derivative, we know we can read the values. At 0, the value of the derivative is 4, right? And at 1, the value of derivative is more than 4. So this statement is false, correct? So we can straight away say this is false. The graph of derivative is rising as we move from 0 to 1, right? Now, the second statement here is the value of function at 0 is greater than value of function at 4. Now these three statements are for the value of function. Value of function at 0, that means you have to figure out what could be the value of function at 0 and what could be the value of function at 4. And statement is value of function at 0 is greater than value of function at 4. Likewise, here we have two more statements. Second and third are value of function at minus 10 is greater than the value of function at 1, or f of minus 2 is greater than f of minus 4. You can pause the video, answer these questions, and then look at my suggestions. Now, my suggestion here is that when you have this kind of a question, it is better to kind of make a rough sketch of the function itself. Then it'll be very easy to answer all these questions. Now let's look into it. This is the graph of the derivative. At this point, minus 2, derivative changes from negative value to positive value. That is to say that the derivative is kind of, you could say derivative is negative, means derivative is going down, and after minus 2 it is going up. That means what? It means that we have local minimum at this point. Is that okay? So this point gives you local minimum value. Is it okay? Now on this side there is a 0. 0 means there is a turning point on the function itself. Now this turning point should be a maximum since the derivative changes from positive to negative. Positive means increasing slope, right? For the function, this is for the function, and decreasing slope will be negative. So this point should be a local maximum. Is that okay? So what you can do is you can think about, just make this as a local maximum here and local minimum. So it is arbitrary, right? So we don't have real values, but we have kind of graph, right? Now this is a parabola, so the function should be cubic function, correct? So that is kind of a help to make a graph from this. So this is a local minimum, maximum, and behavior. If I go like this here, then it means what? On this side we have negative slope. So let me just extend this graph and make the graph for f of x. So we have kind of like this. So I made a more curve here. Let us say it is kind of like this, and let's say like this, right? So the graph of my cubic function will be kind of like this, right? So this is very rough sketch, but it helps you to answer all these questions. So this is the graph of my function. Do you see that? And how did I analyze it? When the derivative changes from negative to positive, that means we have a local minimum. When it changes from positive to negative, that means slope is positive to negative, we have local maximum, right? So this is a very high point as compared to that point. Now it will be very easy to answer the questions. F of 0 and f of 4, you are going to compare. F of 4 is your local maximum and f of 0 is kind of in between. So f of 0 is not greater than 4. So this is false. Do you see that? Since we know f of 4 is local maximum for us. Now it becomes easier. F of minus 10. Minus 10 is kind of end behavior. It has to be a very high positive value. F of 1 will be somewhere in between. So f of minus 10 is greater than f of 1, and that is true. So f of minus 10 will be a very, very high value. Correct? F of minus 2. F of minus 2 is the local minimum for us. F of minus 4 is on the left side, and we know in this portion this is negative, right? So that means slopes is down for the function. So the value f of minus 4 is greater, so this is also false for us, right? So from here what you really understand is whenever you're given a graph of a derivative, try to analyze. A change of derivative from negative to positive means that the slope of the tangent line on the graph will be negative and then positive. This is the turning point. These are turning points on function, right? So these both of them are turning points. So these turning points are either maximum or minimum on the function. If the graph of derivative changes from negative to positive, it is minimum. If it changes from positive to negative, it is maximum. That gives you an idea. On this side we have a negative tangent, so that you see negative tangent, right? So graph of the function is decreasing, right? So end behavior is very high value, correct? Here on the other side, after this maximum, the graph of the function is decreasing, right? So that helps you to answer such questions. I hope it is absolutely clear. So we'll do a couple of more questions which will be related. So we'll do some questions where we'll try to sketch the graph of the function from its derivative and then analyze further. I hope it helps. Thank you and all the best.